But then when you say it, it's not funny sometimes, right? Anyways, make sure you define your variable. So a fridge displayed can hold up to 900 cubic centimeter. If all we're dealing is the fridge, if that's our x here, then we would just say x can hold less than or equal to 900, right? That would be our answer there. And so that actually tells you that x would be the volume, right? In centimeters cubed, right? So that's technically what would be happening here. In order for the university to offer a Spanish course, it needs at least 12 students registered for it. So, and you can use X, Y, whatever you want, but X would be number of students. Okay, so needs at least 12 students. So we need a number for X that is greater than or equal to 12. Okay, that's what you would put there. A farmer grows potatoes and sunflowers. If you just went X and Y, as long as you know that it's number of, right? In order to profit, she needs to harvest a combined weight of 1,500 pounds. So in this case, it would not be number of, it would actually be pounds of potatoes, pounds of sunflower. But X plus Y needs to harvest a combined. What would you say here? Would you say less than or equal to or greater than or equal to? As a farmer, if you needs to harvest this much to make money, you want this much or more. Wouldn't you agree? Yeah. Yeah. It is implied that it's great, right? 1,500 pounds or more implied. So from time to time, you're not going to see one of those keywords, so you just have to interpret it carefully. A daycare takes care of toddlers and preschool children. Based on the staffing, it can accept up to 50 children combined. So if you've got X and Y, so X is your number of toddlers, Y is your number of preschool children. So that combination has to be, it can be 50, but no more, right? So this combination has to be less than or equal to 50. It's okay to have 0. 0, 0 would be fine. 1, 0, all of that would be fine, but you can't have 50 and 1, or a combination that's greater than 50. Okay, then we get into this word problem, and this is kind of what I wanted to focus on. This is kind of what it's going to be like when you're having to write your inequalities and then ultimately graph them. Okay, so Spence is a DJ and is often hired to play at birthdays and weddings. A birthday event usually takes 3 hours. A wedding takes 5 hours of his time, including setup and cleanup. The fee is $450 and for a birthday and $620 for a wedding. So a lot of information here. And this is what I'll tell you. Sometimes it's hard to define your variables right off the top. Right? You're like, wait a minute, what is, like, is it number of? Is it dollars spent? Like, what is my X and my Y variable? I would say then start writing your inequalities and then go back and see what makes most sense based on your inequalities. That's one of the strategies I use. So let's give this a try. Spence has at most 40 hours of per week available. Okay, so let's see here. When it comes to hours, let's see if we can highlight. When it comes to hours, what would we be looking for? We would look for the time it takes, right? So we've got 3 hours and 5 hours. So hours, right? These are the prefixes we're going to use in this case to come up with our inequality. And so I will say 3 hours for a birthday and 5 hours for a wedding, right, to DJ, that combination, right, that number that I would be getting there has to be less than or equal to 40. Okay? So hours match up with hours. I think at this point you can probably already think that X is going to be the number of birthdays, Y is going to be the number of weddings, right? Like you can probably deduct that already at this point. Let's do one more. Next is money, okay? You would like to earn at least $2,300. I'm going to go and look at, right, the dollar amounts that I have there. I'm going to use that to write my inequalities. So if it's 450 for a birthday, 625 for a wedding, right? And you want to earn at least $2,300, that means that whatever number of birthday parties and weddings you run, you want that to be greater than or equal to 2,300. Okay. Spence would like to DJ at most 9 events combined per week. Emphasis on combined. It doesn't say 9 weddings or 9 birthdays specifically. It's like all combined. You don't care what the combination is. In this case, it's just, if it's the number of we're talking about, all you have to do is x plus y, has to be less than or equal to 9, at most, right? Emphasis on at most. He would like to DJ a minimum of 2 weddings per week, a minimum of 2 weddings, specifically to weddings only, right? So my wedding variable is y, that's what I've determined, and that has to be greater than or equal to 2. So this is specifically just to one variable. What kind of a boundary line would this be if it's y and a number? Vertical or horizontal? It's horizontal, right? Fun stuff. Fun stuff. Define your variables and write the inequalities for all the restrictions. That should have been probably at the very top. I don't know what happened there. But we can let x be the number of birthdays, y be the number of weddings. And what do you do if it asks for the implicit constraint? I would do this no matter what, that we're assuming that both x and y are greater than or equal to 0. And we also know that this is discrete data. How do you know that? Because you count the number of birthdays, you count the number of weddings. You can't measure that, right? So there you have it. So that's how you would write one of these. And obviously we could actually graph this if we had wanted to. Let's go to the back side, 45. Okay, a food stand sells pulled pork, sandwiches, and hot dogs. The cost to the owner of the food stand is $1.25 per sandwich, 50 cents per hot dog. The owner of the stand profits $2.50 per sandwich. Profits is makes money, right? So there's a cost in dollars and there's also a profit in dollars. So it's $2.50 and $1.50 respectively. Okay. So the owner of the stand has a budget of $7.50 for all the supplies needed to sell both products. So here, if you have a budget, that means that we're talking about how much you can spend, right? So spending on costs, right? So we would say it's $1.25 for a hot dog, for pulled pork sandwiches, and 50 cents for a hot dog, and that combination, right, however many you choose to purchase, when you plug that in, it has to be less than or equal to $7.50. Okay? The food stand has enough supplies to serve 650 sandwiches and hot dogs combined. Here we're just talking sandwiches and hot dogs combined, the number of. So we go x plus y has to be less than or equal to 650, right? The number of hot dogs and, pulled pork sandwiches and hot dogs would be has to be less than or equal to 650. This is the number of we're talking about, like how many you are serving, okay? The owner would like to profit at least $1,000. I'm going to highlight this one because here we're dealing with profit specifically. So then we would want to use the 250 and the 150 when it comes to profit. So 250x plus 150y, that has to be at least $1,000. This is a tricky one here. You ready for this one? This is always a bit of a head scratcher. You ready for this? The owner of the stand would like to sell at least twice as many sandwiches compared to every hot dog. Okay? Let's do this carefully. Let's think about it first. I like to have, let's imagine you sell one hot dog, one sandwich, my bad. Let's keep the order the same. Let's say you sell one sandwich and one hot dog. Okay? So for every sandwich you sell a hot dog. Okay? I think you can all wrap your head around that. What if I told you, though, that you want to sell at least twice as many sandwiches compared to the hot dog? Okay? What you would want to do is you would want to say then, well, however many hot dogs I sell, I want twice as many for this one. Okay? So what you have to do is you actually have to multiply this by 2. Now you can say for every sandwich, right? For every hot dog, you will sell twice as many hot dogs for every in comparison. Okay? So in this case, what you need to do is, I like to have the y and the x like this. And you want to sell more sandwiches. Okay, more sandwiches. So we're going to you want more sandwiches than hot dogs, for sure. So you want that to be greater towards the x. Okay. And you're going to put a 2 in front of the x, like that. So that's the inequality that it's talking about here. And the most helpful exercise here is go through a scenario, right? So let's say, did I mix this up again? I think I did. Because these are my sandwiches, right? And these are my hot dogs. Sorry, can you take this 2 away? Stop confusing me. Okay, let's walk through it slowly again. These are my sandwiches. These are the hot dogs. Okay, we could have defined that right off the top. So sandwiches, hot dogs. Okay, sandwiches, hot dogs. I just kept them in that order. If you want to sell at least twice as many sandwiches for every hot dog, you want to sell more sandwiches. Okay? So you want x to be greater. And what you need to do here is you need to put the 2 in front of the y. In front of the y. That's what you want to do. Okay? And if you think about this, you ready for this? Let's say you sell 1 hot dog, right? This would be a 1, right? Then you go 2 times the 1 hot dog. Then all of a sudden you're saying x is now going to be 2, right? When you have 1 hot dog sold, you plug that in there. 2 times 1 is 2. So x would have to be greater than or equal to 2. Let's say you sell 2 hot dogs, right? If you go 2 times 2, that's 4, right? So now you're saying x has to be greater than or equal to 4, right? So that is kind of like the mental exercise you want to go through. So it's counterintuitive. A lot of you would have probably read this and said at least twice as many sandwiches. Oh, twice as many sandwiches, let's put the 2 in front of the x. It's counterintuitive. Okay? So this is a common error. Maybe let's write the error down. This is saying the exact opposite, right? So this is not correct. Define your variables, x and y. X would be number of sandwiches, and y would be number of hot dogs. X and y is greater than or equal to 0. And it's discrete as well, discrete data. There you have it. Okay. One more. It's very important to have this right. And I don't know if you did all of this, so I'm just going to assume maybe you were struggling a little bit, or maybe you weren't sure what to do. So Emily has 2 part-time jobs, working at Canadian Tire and Wendy's. She earns $11.45 at Canadian Tire, $12.50 an hour at Wendy's, which is, that would not be right, because what's minimum wage now, 15 something? 16. My first job, minimum wage $7.50 an hour. $7.50. It sounded like, even back then it wasn't a whole lot. So you remember the days where it's like, oh, I could buy a meal for a penny or something. Remember those days? I don't know if you've heard your grandparents or whatever talk about those. $7.50 wasn't a whole lot of money back then. It isn't a lot of money here now, right? So anyways, stop complaining. Just keep going. Emily would like to work at most 30 hours per week. So this is just between the 2 jobs, right? At most 30 hours. So how about this? I will say that this sentence right here, there is a restriction on time. And I would call this inequality 1. Okay? There's a restriction on time given here. Canadian Tire requires Emily to work a minimum of 9 hours per week. This would be inequality number 2 that I see. A minimum of 9 hours, specifically for Canadian Tire, right? Emily would like to earn at least $225 per week. This is inequality number 3. There's 1, 2, 3. And you might say, well, what about this one, Mr. Dirksen? Isn't that an inequality? Not really. That's just information, right? How much you're getting paid per job, per hour at each job. So let's define our variables and come up with our inequalities. X, Y. You may have started like this, and it's fine. Canadian Tire and Wendy's. Okay? You may have done that at first. It's not quite correct, I would say, at this point, but let's continue. X and Y greater than or equal to 0, and we don't know if it's discrete or continuous just yet. Let's write our inequality. The first one, working at most 30 hours per week. X plus Y at most, that means that the hours that I work has to be less than or equal to 30. That's inequality number 1. Right? This is IQ 1. IQ 2, what does the second one say? Canadian Tire requires a minimum of 9 hours per week. For me, X is Canadian Tire, so I will say X has to be greater than or equal to 9. A minimum of 9 hours worked at Canadian Tire. IQ 3, we're talking about money. Okay? So how would you do this one? You would say, well, it's $11.45 at Canadian Tire, and it's $12.50 at Wendy's. And that combination has to be greater than or equal to 225 because it says at least. Okay. Question. What would x and y be in this context? X plus y is 30. X plus y is 30. So wouldn't this be the number of hours, right? Same with working at Canadian Tire. You have to work at least 9 hours. This has to be hours. Getting 11.45 per hour, so 11.45 for every hour you work there, 12.50 for every hour you work at Wendy's. So it's actually hours. So if you could just do this in your notes, like tell me what the units, is it number of? In this case, it wouldn't make sense. Number of Canadian Tire. It has to be hours, right? Specifically, which makes this continuous. Okay, there aren't that many continuous examples, but when it's hours, when it's volume, anything like that, continuous is the way to go. All right, I'm going to give you, I'm going to check